This first section is a lot of notation and vocabulary associated with angles and also triangles. So we have a definition for degree measure, supplementary, complementary angles, right angles, straight angles, things like that. Let's go to the board and work a couple of problems. Here it says give the complement and supplement, and problem number 1 says 10 degrees. So I'm going to say the complement of 10 degrees is the angle that I'd have to add the 10 degrees to get 90 degrees. So its complement must be 80 degrees because 80 degrees plus 10 degrees is 90 degrees. To find the supplement, I'm looking for the angle that I add the 10 degrees to get 180 degrees. That must be 170 degrees. So complementary angles always add up to 90 degrees. Supplementary angles always add up to 180 degrees. If our angle is x degrees, then its complement is going to be also the angle that I would add to it to get 90 degrees. Well, the thing I add to x to get 90 is 90 degrees minus x. So the complement of x is 90 degrees minus x, and the supplement is what I add to x to get 180 degrees. That's going to be 180 degrees minus x. So complementary angles add up to 90 degrees, supplementary angles add up to 180 degrees. Let's look at our next problem. Through how many degrees does the hour hand of a clock move in 4 hours? So what we want to know is this. Here we have a clock, let's say. Here's the hour hand at noon. At 4 o'clock it's going to be pointing down here. We want to know about how many degrees are in that angle. So what we'll do is set up a little proportion, and we'll say this. However many degrees that is, x degrees is to once around that circle, 360 degrees, as 4 hours is to once around the circle in hours, which is 12 hours. So x is to 360 as 4 is to 12. I multiply both sides of this equation by 360, and I get x equals 4/12 times 360. 12 divides into 360 30 times. 4 times 30 is 120. And of course that's in degrees. I'll put my little degree symbol in. So I get 120 degrees. And that seems to make sense. This looks like about 120 degrees. It would be 90 degrees right here, and then 180 degrees all the way down to here. So the hour hand of a clock moves through 120 degrees every 4 hours. So I just started at 12 and went to 4, but you could start at 4 and go to 8, 8 and go to 12, whatever you wanted. Here's another problem. It says fill in the sides. I have a little right triangle here. Looks like I brushed up against this. This side is 6, right there. This is 60 degrees. That's 6. That's 90 degrees. So this must be 30 degrees. So I have one of my 30, 60, 90 triangles, a 30, 60 right triangle. I know for all these triangles that if the shortest side is t, then the longest side is going to be 2t, and the third side is going to be t square root 3. So that means that t square root 3 must be equal to 6. I'll divide both sides by square root 3, and I'll end up with t equals square root 3. Whoops, take that back. T is equal to 6 divided by square root 3. So that's what t is equal to. That would be the shortest side, 6 over square root 3. And then the other side would be twice that, so 2 times 6 over square root 3 would be 12 over square root 3. And then remember with radicals in the denominator, we could, if we want, rationalize this denominator. I'll just do that real quick so we can see what this looks like. Multiply the numerator and denominator by square root 3. The numerator becomes 6 square root 3. The denominator is square root 3 times square root 3, which is just 3. That 3 will divide out with that factor of 3 that's in 6, and I end up with 2 square root 3. So the answer 2 square root 3, that's going to be correct for t, and also 6 over square root 3. This expression and this expression are equivalent. So then my longest side will be twice that. That's either 12 over square root 3 or twice this, which would be 4 times square root 3. So we don't always rationalize the denominators in trigonometry, but you need to know how to do it in case we do.